Welcome back, Calculus. We'll be doing 5.3, and what we need to investigate now is the confusing part of calculus. Because at times you need to justify with a given name, whether it's the intermediate value theorem, extreme value theorem, or mean value theorem. You never have to say Rolle's theorem, but it is something that could be stated if it's a specific instance of mean value theorem. So as a reminder, you may want to pause the video and write down word for word and maybe reference this piece of paper over and over again in the future. And this is how it would be written in a book. Is as a reminder, because this is from Unit 1, I believe, that the intermediate value theorem is just saying if we have a continuous function on a closed interval, then there's some value c on the open interval. I guess I should also mention that this k value is somewhere between f of a and f of b. K is a y value, by the way. That there is some c in the interval such that f of c is equal to k. Intermediate value theorem. The extreme value theorem is what we covered in section 1, which also needs to be continuous on a closed interval. And what it's saying is that the absolute min and max, or absolute extreme, either occur where the derivative is 0, where the derivative is undefined, or at one of the endpoints. It doesn't have to be, but in the absolute min and absolute max must occur at one of those locations. So in section 2, we wrote all of this down, Rolle's theorem and mean value theorem. And again, you may want to pause, get everything written down just like it was a textbook. And the Rolle's theorem is the same thing as the mean value theorem, except because Rolle's theorem has f of a equals f of b, then the slope here will equal 0. Now, how do I distinguish between these theorems? Well, extreme is easy for me because it deals with absolute min and max. That makes sense. I like to think of mean starts with m, and m is the slope. So mean value theorem is the derivative is equal to the slope. I know it's kind of a stretch to think of it like that, but it helps me. So anytime you're dealing with the slope, the instantaneous rate of change is equal to the average rate of change. That's the mean value theorem. And if you're ever asked to justify, and you want to justify using the Rolle's theorem, then you better have the y values are equal. But you don't ever have to justify with Rolle's theorem because you can just say by the mean value theorem. And it happens to be that the y values are equal. So that's my professional opinion. And then by trichotomy, if it's not the mean value theorem, if it's not extreme value theorem, then it must be the intermediate value theorem. That's how my brain works. So again, go ahead and pause the video if you haven't already. And I'm going to go back to the notes. And talk about these problems. So notice that they give you the rate at which water flows out of a pipe. So this is R of t, this is a rate. The table shows below the rate measured every 3 hours for a 24-hour period. So estimate the value of r prime of 5. Well, 5 is not a value in here, so I would look at values on either side and it's clued in that you have to estimate. So r prime of 5 is telling me that I better do the average rate of change, which would, I would do 6 minus 3. I just like having my x's in the denominator to be positive. So that means I have to do 10.8 minus 10.4. So that's 0.4. And if you wanted to divide that, you could, or how about just get a calculator out? 0.133. If you want to write repeating over that, that's fine. Now notice that we found the r prime, so that's the derivative of this rate. So what that means is I need to do gallons per hour, which is the rate of that, per hour. Gallons per hour, or I like to write gallons per hour squared. So what does this approximation mean? What does this mean? Is I would write something along the lines of because we have a positive value, that means that the rate at which the water is flowing out of the pipe is increasing. This person didn't even write the units down, but something along those lines. Oh, I guess they went ahead and did the next one. Excuse me. So as you look at the next one, I'll just go ahead and show you since I already have it shared right here. Pretty much the same thing. Average rate of change from t equals 3 to t equals 18 is really the same thing. And again, you want the correct units of measure. So is there some time between 0 and 24 where the derivative must equal 0? And so as you're looking at this, you want to double check the directions. And part of those directions will be including that it's a differentiable function. A lot of times they'll even say a twice differentiable function to cover all their bases. I think the author just kind of forgot to add that in there. So the whole premise of this is, as you can tell, we are in the rate is going up, 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 down. And so you could say the only way to go from increasing to decreasing on a differentiable function would be if we get to r prime equals 0. But a somewhat safer answer would be to find where the y values are the same. And a quick answer would be at the endpoints. Okay, so what we have is we have a differentiable function. Differentiability implies continuity. So that's important to mention on the open, so it's differentiable on the open interval, it's continuous on the closed interval. And because r of 0 is equal to r of 24, and I believe it was 9.6, I can go back up there and double check that. Then what we can state is that Rolle's theorem applies so that there's some, you can call it t, but some c, so the kind of the goofy symbol is the backwards e. There exists some c on that interval from 0 to 24 such that r prime of c is equal to 0. And there could be other ways of writing this, and again, I'll defer to the answer key. And he actually writes it out instead of my goofy symbols that are actually pretty universal in the math world. Rolle's theorem guarantees a value of t on that interval such that r prime of t equals 0. So you can even rewrite such that as s dot t dot. That's how lazy we are in the math world. So feel free to pause this as we move forward with some more distinction problems. So what we have is a formula. It looks like it's a cost equation, and we can answer these problems. The cost equation is just measured in dollars. So is there guaranteed a value of r on the interval from 0 to 3 such the average rate of change of cost is equal to c prime of r? Well, what you might want to discover from this is when we look at this C prime of R, this is typically a clue that we're going to be looking at the mean value theorem. And think about from the derivative, if we're looking for the mean value theorem, is the function must be continuous on the closed. I think all of them actually need to be continuous on the closed interval. So as you look at some undefined values, go back up here and say, well, what can x not be? Well, x cannot be, can't divide by 0. And we can't divide by 0, so x cannot be -3 on this one. So deducing from that, one of our bounds is ruined, so to speak. So since x cannot equal 0, c of x is not continuous on the closed interval. And therefore, average rate of change is equal to the mean value theorem does not apply. So as we move forward to the next problem, is there value such as c prime of r is equal to 0? That's where, so again, this is seeing the derivative here makes me think of the mean value theorem, but because it's equal to 0, that's a very specific. So what the intent is of this problem is really Rolle's theorem. But remember, you can just explain it using the mean value theorem and deducing that the slope of these values will be 0. So I would actually use a calculator just for the sake of, I guess, ease in this problem. So where's my calculator? Go to y equals, and type in that equation. I think it was 10,000, wasn't it? Yeah. 1 over x, and then plus x over x plus 3. And you don't need to go to the graph of that. But what I'm going to do now, it would be faster if I just go to the table second graph. And when x is 3, I get this 25,000 over 3. And at x equals 6, I get the same value, 25,000 over 3. So several things to check. Okay, first of all, this function is differentiable and continuous. I do need to be careful because there is a difference between being differentiable on the closed interval and continuous on the open. I said it wrong. Differentiable on the open and continuous on the closed. And because f of 3, c of 3 is equal to c of 6, which equals, I think it was at 25,000 over 3. So now what we can actually do is find that derivative. I guess I should have left it up here. And if I were doing this problem, I would actually rewrite c of x. Just because I don't really like the way it's written. 10,000. I wouldn't want to do the chain rule or product rule. I guess I'd have to do the quotient rule on that one. So that derivative, c prime of x, would equal -1,000. I'm running out of